So yeah, I'll be representing OpenZeppelin here and all our efforts to build an ecosystem for Stylus. So I think we've been developing our project for almost 1 year, and we are here to share what we could make and what problems we encountered. So let's start with design of Stylus contract. Basically, Stylus should be compatible with EVM. So Stylus contract should be interchangeable. And but for Solidity developers, there are differences, and there are differences between Solidity and Rust, and of course, its main problems that should be highlighted. And let's go next. First thing is lack of constructors. At Solidity, it's typical object-oriented language, and constructors are same as C# and Java. So, but at Stylus there is no so, and it should be some workarounds been made to be able to construct a contract. Inheritance, it's not like that. Errors, yeah, there is a different approach in Rust for errors. Calling the other contract is also a bit different, and there is another aspect with selectors. So let's dive into the first one. And yeah, as you can see, there is a first straightforward approach for typing your contract. You will be using trait, and in this trait you'll be using constants. But the problem is that it will be done at compile time. So if you want to execute some code during deployment, it's impossible. But it's still enough to pass some string parameters like name, symbol for ERC71, for example. The other approach you should have function initializers. You can call it init, but technically it will be function exposed. And the deployer should call that function. And of course, you should consider that there is a possibility that malicious actor will call this function right after you deploy contract. So you should also check for address. And this is also not perfect, but I still think that's like kinda first option is preferable. Second one, if you really need it. Actually, at OpenZeppelin, we are not doing neither first one, neither second. So we devised the other approach. I'm not here to advertise it, so we will drop it later. But yeah, it's called COBA. It's basically tooling that allows you to call constructor written on Solidity. So here you can see this is code written on Solidity, just for ERC20, for example. And this file should be placed next to the contract written on Rust. It's not perfect, but it actually can happen like within a single transaction. There are still many problems around this design. For example, you should keep same order of fields because it should be tied to the fields in your Rust contract. And but yeah, it's still something, and we're expecting that that problem with constructors at Stylus will be solved later. Inheritance. So there is no inheritance in Rust. You cannot just take one struct, inherit from the other one. You can use trait, and you can use a syntax that looks like inheritance in Solidity, but actually just generic restriction on types. So there is no virtual functions, so there is no word virtual. Of course, it's reserved in Rust, but no, it is not part of the language. And the other problem that there is macro at Stylus SDK, inherit macro, but it doesn't work for 3 levels of inheritance. So just an example of contract that won't be able to be compiled. So you see top level contract, second level contract contains third level contract. And here is where error will be highlighted by your compiler. yeah, it doesn't work. Of course, you will try, once you see this problem, you will try to solve it, for example, this way. And it's extremely dangerous. So you just put third level contract to the top level, and you duplicate it into places here and here. So and the worst thing that can happen with this solution that you will think that it actually works, it can pass test, but in reality you just duplicated your contract storage 2 times. In OpenZeppelin, to hire a new teammate, we're conducting work test, and every person passed through challenges. So the last challenge is mostly related to the project. So we recently hired new teammate, but of course more people have been passing that work test. And that is one of the problems that every experienced software engineer that passed all previous stages encountered. So it's not trivial. And yeah, I want to highlight that never do it. So let's go next. Yeah, basically, since you cannot use, if you look at the contract as a tree and 3 levels, depth of 3rd level is impossible, so you can use it just once. Yeah, and pardon? Yeah, you can use it just once, and of course it makes sense to use it just in the contract of library consumer. So, and the other contracts not using inherit keyword. So, and it works just in entry point contract. So entry point at Stylus SDK means that exact contract that will be compiled to WebAssembly. So like the least unit of compilation. And the overall approach that you should take, or at least we're trying to take at our library, is using composition, using wrappers, so, and not relying on inherit keyword. So just put one contract in the other, and then let the library user just expose those functions, those methods that he needs. So, and of course, in this scenario, it's not necessary to use borrow attributes because it's pointless. It's necessary for inherit macro and no limitation for inheritance tree. So with errors, it can be quite simple. If you need just to use, for example, our smart contract, and you don't want to mess with typed errors in Rust, you can just use raw bytes and return them. Just map typed error to vector of bytes, and that's it. It can work for simple scenarios, but for libraries, of course, you should have some more sophisticated approach, because otherwise it would be very hard to test. Let's go next. To make an external contract, for example, you have one contract, you want to call the other one. Classic example is ERC71 and receiver. It's widely used at OpenZeppelin Solidity library, and in our library for Stylus contracts we're also following. So basically, this is example taken from our code base, maybe a bit simplified without comments, but yeah, doesn't seem complex. Anyway, it's a bit more messy than it's in Solidity, but yeah. And you should pass always top-level storage in call. The other difference of Stylus contracts with Solidity is that it's impossible in Rust to have 2 methods with the same name. It's possible in the other languages like Solidity, C#, Java, but in Rust you can do it. And this is another problem that our contributors, or for example, candidates that have been passing work test to OpenZeppelin, like they've been challenged of it. So, and they've been asking questions, what's wrong? So, of course, it's solved quite simply. In Stylus SDK, just indicate exact name for selector. But yeah, everyone got stuck with that question. Okay, here I want to cover a few topics about designing a library. Previously, I was highlighting design of contract that you want to publish by yourself, and if you want to create some library that someone else will be using. So what you should pay attention to, errors. So yeah, of course, to be able to correctly test your library, to navigate, to have documentation, it makes sense to rely on Rust type system. So, and that is how you can compose errors. Same as you compose contract. For example, current contract, it's a consecutive extension of ERC-71 of NFT. So it contains ERC-71 inside, and same works with errors. You can indicate error in the enum as an argument. For checkpoints, same. You take errors from checkpoint contract and put it there. So errors can be declared in solidity like style. Of course, one crucial thing that you should implement method error for all underlying errors, so otherwise it won't be compiled, but it's quite simple. Maybe in future it will be included in this macro, and it will get more convenient. Also, in terms of making your functions public, technically you can just implement methods in your contract without any trade, but we at OpenZeppelin thinks that it's much better approach, more versatile, since you declare the contract just once in the trades, and implementation is left only to user. So yeah, currently this approach will work. So you just declare trade, and using public keyword, you can write your own implementation. Or for example, you want to have a bit different contract from ERC-20. So you can use reuse same trade, but use composition to store ERC-20 contract and basically forward calls to corresponding functions and override those that you don't need. The other good thing about interfaces, I mean trades, in Rust it's called trades, so that you can implement interface IDs. So at Solidity there is a pattern, there is a standard ERC-165 that allows to show the other colleagues what is exact, so basically validate set of functions of your contract. So, and it relies on one important fact that that every contract has selectors. So, and those selectors compose interface ID. So basically, selector is hash of function signature and name of the function and all types of arguments. And interface ID is XOR of all of those items. Technically, if you change, for example, here, token ID, you will change type, the overall interface ID will be totally different. It's quite obvious that it will be a completely different number, and that is quite convenient to colleagues to make sure what is the actual contract looks like. So at Solidity, it's done quite simple. Interfaces expose property, but at Stylus there is no that thing, and you can just implement interface ID by yourself. So here you can see that we basically compute Qoshqosh and XOR of every every selector. Or you can write your own macro. So it's currently exists at OpenZeppelin library, and you can use it. We're using for ERC-165. And then expose function support interface that will check that exact contract support that exact interface. Let's go next. So the other important thing for library is to be able to validate that it works. So to be able to make sure that all test scenario pass, and for example, for us, for OpenZeppelin, it's important to pass security audit and to have for auditors the best tooling and the best environment to check if something works or doesn't. So we implemented end-to-end testing, and yeah, if you're developing your own library, also strongly advise to have something like that. Currently, we are not published yet our library for end-to-end test, since it relies on some infrastructure on Nitro test node that you should deploy, and maybe in future it will be available. But yeah, by the end, for end-to-end test, you should have Docker installed. You should run Nitro test node. It will take some time to set it up, so it's not long process. I think our pipelines take like almost 10 minutes to pass all tests altogether with setting up Nitro test node. For calling the contract, you need some kind of RPC, so you can use Ethereum or LA provider. We use last one. And you should compile your entry point contract. So ideally, you should have some contracts for test, or like we have examples, and every example that is documented, it also well tested. So then you can write test scenarios. Basically, in this test, this end-to-end macro desugars quite simply. It just initializes every account. In reality, underneath, it called default function, so it's known pattern in Rust to have a default initializer for a function. So, but in reality, it just calls shell script a Nitro test node that was previously cloned and found that exact account. So that is currently how it works. Maybe it looks quite simple, but in reality it is not. So, and that is why it's hard to publish it as a separate grade. And same here, we're just deploying our contract, but yeah, again, we're calling something, we're doing some thing with Nitro test node here. So I think we can go next. Oh yeah, technically, as I mentioned, that end-to-end test require more time to pass, and it has infrastructural dependencies. So, and it would be really cool to be able to run your testing suite in memory. So, not call Docker container and then waiting for consensus. So, unit test could help, like check your contract in very fast way. So, as I mentioned, no Docker is necessary. Test can pass fast, and that open way for fuzzing test when you can run single test but with different set of arguments. So many times just hoping to find some error or mistake and then record artifact that produced failure. So of course you still cannot test it on chain if you're using memory. You can't use it with Solidity contract. You cannot deploy Solidity contract and Rust contract in memory. So it would be too complex. So you should still use end-to-end test for it. But yeah, and it requires some understanding how basically Stylus works. So I'll try to shed some light on it. Basically, Stylus contracts are linking, so and they're calling some other code, some library. So and our idea is to mock that call. And at OpenZeppelin, we have a library that's called Motsu. Basically, I don't remember why we called it like that, so it's something on Japanese. We're expecting to rename it to something that sounds better, like OpenZeppelin test. So, but yeah, currently it's called Motsu. Yeah, and what is it doing? It's mocking every call to the host, and it replaces that call with some in-memory storage. So in this example, just every operation with Stylus contract desugares to writing bytes, so cache bytes or loading bytes. So there is nothing complex. So we have a key and basically the value that you pass every time. And what you need just to mock that. So, but there is a problem that that shim is same for every test. So, and test and Rust are by default run in parallel. So, and technically you need to synchronize them somehow or make it possible to run it in concurrent way. So, of course, you can use mutex for this purpose and store those and for every test, store a set of mock data, mock storage, and also you can store, for example, mock value or mock address that's going to execute the transaction, or how much Ethereum you're going to send. So in our case, at Rust, good thing that every test case runs in separate thread, and it has a unique thread name that basically matches the full name of the test case, module name, and function name of the test case. So what we need to do is just to take the thread name and use it as a key in some concurrent hash map. So in this example, we're using dash map, and it can work. And in this case, all test cases run concurrently in parallel, and basically it is enough just to mock storage data. And that is how test cases can look like. So yeah, Motsu is the name of the library, and the contract is basically exact contract on which you can do some operation in this test case. In future, we're expecting to add some improvements. So, for example, being able to set message sender who's sending transaction, not hard-coded, or pass some value, for example, set amount of Ethereum that's been sent, or deploy a few contracts. So, but of course it would be Rust contracts, and I guess yeah, there is a quite extensive roadmap for Motsu, and yeah, we expecting to implement it. Also, other important thing for your library, since one of the selling point of Stylus is that it should be cheap. So, of course, we are not going to use contracts written on Solidity because in some cases it can consume quite a lot of gas. So, and the good thing is store a footprint every time you add new changes to your library. So run some benchmarks and record those data. Important is that you should pin to a specific Rust version or Nitro test node version. So to make sure that changes in your benchmark being produced not by infrastructure but by your code. So to better understand what's happening. And that is basically screen, the snapshot of our pipeline for ERC20. So, of course, it's possible at Stylus to cache contract, and gas price will be a bit less for the call. So it basically 20,000 way less. as you can see. But overall, it looks quite good. I mean, overall solidity is a bit better, but it's because those are simple contracts. So there is no heavy computations in ERC20, and mostly we are writing to storage or taking values out of it. And same for ERC71. So technically, we have much more benchmarks, just a bit what I shared. Also good thing to store in your pipelines to record what are sizes of compiled binaries. So because we noticed that sometimes it can be quite big, and by the end you won't realize what introduced those changes and why your contract cannot be deployed. So I think that's it. Thank you. Do you have any questions?
Thank you very much, Alisander. That was amazing. To be honest, it's super cool to see what you're building with Stylus, and for sure, always great to have the OG OpenZeppelin team doing audits to the Arbitrum code. And yeah, thank you very much. It was amazing.
Thank you.
Woo!